Okay, let me start from section 1.1. And you can always stop me and ask question if you have any, okay? So feel free to ask any question if you have. Okay, in section 1.1, so we have 1 and 2, and we are asked to solve the equation. So let me start with number 1. So in number 1, so we have 3 times x plus 4 minus 2 times 2x plus 1 equals to 13. So this is an equation. Okay, we know from this equality sign, this is an equation. We have a variable x and we are asked to solve. Solve means we need to find a value for this variable such that this mathematical statement is true. Okay, we are solving this equation for x, and solving means we are making our variable by itself in one side of the equation. Okay, now here, so we have 3 times x plus 4, okay, negative 2 times 2x plus 1 equals to 13. So let's distribute this 3 to each term inside this parenthesis. So you distribute 3 to positive x and 3 to 4. Similarly here, you distribute negative 2 to positive 2x and you distribute negative 2 to positive 1. So this gives us 3 times positive x, positive 3x, 3 times positive 4, positive 12, negative 2 times positive 2x, negative 4x, negative 2 times positive 1, negative 2 equals to 13. Okay, now the next we look for the like terms. So we have 3x and negative 4x. These are like terms. Similarly, we have positive 12 and negative 2 as a like term. So positive 3x, negative 4x, that is negative x, positive 12, negative 2, positive 10 equals to 13. Okay, now we get rid of positive 10 from left side. For that, we subtract 10 on both sides. So positive 10, negative 10 is 0. So we are left with negative x equals to 13 minus 10, which is positive 3. We still have negative, okay, with x. We need to get rid of this negative. For that, you can multiply both sides of the equation by negative 1, or you can divide both sides of the equation by negative 1. So here, negative x divided by negative 1 positive x equals to 3 divided by negative 1 negative 3. So the value of x has to be negative 3. Okay, if you substitute negative 3 for every x in this equation, we end up getting same number on both sides. Okay, now does anyone have any question for number 1? And there will be one linear equation you will be asked to solve. Okay, you will be given an equation very similar to this one, and you have to solve that equation. You have to find the value of x. Okay, looks like no one have question for me. Okay, if that is the case, let me go to number 2. So in number 2, we have 3x minus 1 divided by 5 plus 1 plus 1 equals to 1/2. Now, can anyone tell me what is the type of equation is this? So in chapter 1, we talk about the linear equation. We talk about the quadratic equation. We also had a rational equation. We had a radical equation, and we also had an absolute value equation. Now, what is the type of equation is this? What do you think? Can you guess? Is it a linear, rational equation, or radical, absolute value, quadratic equation? What type of, okay, rational, okay. Does anyone have a different answer, or linear? Okay, so this is linear equation. Okay, so this is not rational. Now, every rational equation has a variable in the denominator. Okay, now we have this 5 as a denominator. This is a constant. But in the rational equation, you always see at least one variable in the denominator. Okay. Now here we can rewrite this here. So we can rewrite this as, I mean, you are not required to rewrite on your exam, but let me show you here. So we can break it down this as a 3x divided by 5 negative 1 divided by 5 plus 1 equals to 1 half. And this is 3 over 5x minus 1 over 5 plus 1 equals to 1 half. Okay, now this equation has a variable x and it has a degree 1. So the highest degree for this equation is 1, and the equation is linear. Okay, so if you have equation and the degree of a equation is 1, it is always linear. Now, if the equation is linear, what is the number of solutions that we can find for that equation? Like how many solutions does linear equation have? So what is the number of equation? How many equation can we find for linear equation? Okay, it's one. Okay, like in yes, it's one like in number one. So this is also linear equation, and we have one solution. Every quadratic equation have at least two solutions. Okay, now let's go ahead and solve this equation. This is a linear equation. Let me rewrite one more time. We have 3x minus 1 divided by 5 plus 1 equals to 1 half. Okay, now we will follow the method of solving rational equation. Okay, for this one, we have a fraction here. So in order to solve this, we find the common denominator. Okay, so this one has a denominator 1. So we have a 5, 1, and 2 as a denominator. So what will be the common denominator for 5, 1, and 2? 10. Okay, that's good. So 10 is the common denominator. So let's multiply each term of this equation by 10. Okay, you are multiplying every term, okay, by 10. So you multiply every term. Okay, so you are multiplying this expression by 10, this expression by 10, and this expression by 10. Now let's simplify this. So 5 times 1 is 5, 5 times 2 is 10, 2 times 1 is 1, 2 times 5 is 10. Okay, let me rewrite this. So this is 2. Now we have a times here. So times 3x minus 1 positive. 1 times 10 is 10 equals to 1 times 5 is 5. So we have 2 times binomial. So we distribute this 2. So you distribute to 3x and negative 1. 2 times positive 3x, positive 6x, 2 times negative 1, negative 2, plus 10 equals to 5. We look for the like terms. These two are like terms. 6x minus 2 plus 10 plus 8 equals to 5. Now we get rid of positive 8. You subtract 8 on the both sides. This is 0. So we have 6x equals to negative 3. We still have 6 with x. Now in between 6 and x, we have a product. And in order to get rid of this 6 times x, we divide both sides by 6. 6x divided by 6 is x equals to negative 3 divided by 6 is negative half. And this is the solution for this equation. Okay, does anyone have any question here for number 2?
I have a question. When we found that our common denominator would be 10, I in my head initially I was thinking of multiplying 5 times 2 to get 10 and then 1 times, 10, but why would we not do that and instead do your way, which would be to times it all by 10 rather than doing 5 times 2 to get 10?
Okay, so you mean to multiply 5 and 2 and 1 to get common denominator?
Yes, yeah, because I did know, like, looking at it initially, that our common denominator, like, they should all have factors of 10,
Right.
but um instead of multiplying all of them by 10, I
Mm-hmm.
was thinking initially my first gut was to be 5 times 2, not 5 times 10. Because I know 5 times 2 will get me 10.
Mm-hmm.
Does that make sense? My question,
Okay,
sort of.
let me take something different. For example, if we have something like 2 over 20 plus 4 over, okay, let me say 6. So, uh, okay, not 6. Let me take something different. Okay, let me take 8. So what would be common denominator like from your way? How would you find the common denominator if you are adding these two fractions?
Well, I
So
would
do you
think
want to multiply 20 and 8? I mean, you will end up getting the same answer, but it's
I
gonna,
would.
yes, go ahead.
Oh, I was thinking I know 8 could go into 40.
Mm-hmm. Right.
So, in my head, I would, when I look at this, I would do, because I do this, I think, and this is maybe what I'm doing wrong on like my quizzes and my work, but I would do 20 times 2 to get me 40, and then I would do 8 times 5 to get me 40, but that would be incorrect. Instead, it sounds like I should be doing your way, which is what we did. Is that right?
Okay, okay. So you will be doing, you multiply both the numerator and denominator by 2 here and by 5 here, right?
Yeah, that's what I'm doing, but that would be incorrect, right?
No, this is correct. Okay, let me go back to your question. Okay, repeat your question. I'm okay, like, yeah, just repeat that.
My question was is um when finding the common
Mm-hmm.
denominator or factor
Mm-hmm.
in what we just did up above, and we I knew that it had to be 10, but instead of multiplying all of them by 10, I would actually multiply them by different numbers. So like to get 10 for the first part of the equation, I
Okay,
would do 5 times 2, not 5 times 10.
so you multiply by 2 here, right?
Yeah, to get me 10. And
Okay,
then
so what do you do here?
oh, oh, where you just
Oh, I'm
circled?
sorry, not this one. So here you multiply by 2. Okay, so here, what you will do?
I would multiply the bottom because it's over 1 by 10.
So you multiply by 10 in the numerator and denominator.
Yes, that's what I would have done. And
Okay, and whatever
for
here.
yes, and then for this one I would oh, see, I could see why this wouldn't work well for me because I would do them both differently at the top and bottom. Like for the last one that you just circled, I would do times
5.
5 2 at the bottom, but that wouldn't work for the numerator because I have to get it all to be 10, right?
Yes.
Okay, I see. Thank you for walking me through it. Sometimes I
I think you
just
can still, this is not incorrect. Okay,
oh,
so okay, now, okay, let's do your way. Now here, if you do here, so we end up getting 2 times 3x minus 1 divided by 10, plus 10 divided by 10 plus 5, sorry, equals to 10, 5, sorry, equals to 5 divided by 10. Now we have a common denominator. So this is 2 times 3x minus 1 plus 10, we write together and equals to 5 over 10. Now to get rid of this 10, we multiply both sides by 10. So this is cancelled, this is gone. We end up with 2 times 3x minus 1 plus 10 equals to 5. And you will get the same answer like we had here, 1/2. So it's not
okay.
wrong.
Okay, thank you so much for clarifying that. I just wanted to ask these silly questions just to make sure that like what I'm doing would still work out correctly for me.
That
So
does
thank
work. I think it might add like extra work, but I think it's still correct. Okay.
okay, thank you. Thank
All right. Does anyone have any question with number 1 and 2? And you will have very similar question out of 1 and 2. Okay. So there will be one linear equation and you will be asked to solve. Yes. Okay. I can't hear you clearly. You can just write the question on a chat box. Okay. I can. Okay. Uh, Alone swiping against. I can't hear you
to
clearly.
me, it's a lot easier to do it the way
If you can hear me, I don't
um,
think that we can hear you clearly. I would request you to write me a text on a chat box. We can't hear you. It's not clear. Mm,
you
Okay.
can hear me.
I can't hear you, but I can read your chat. Okay, just let me see what you have here. Mm, Okay. Let's see. Yeah, like as I said, both ways work. Okay, so you can use any method, whatever is comfortable for you. Okay, one more. Okay, let me see if we have any of that type. Okay, let me go back here. We don't have in the review. Uh, okay, let me do one from the rational. Okay, so it's very similar. Okay, let me use a different section review. So from section 1.4, I'll be back. Okay, so from section 1.4 okay, let me do 42, not the 42, 46, 7. Okay, let me do 47. Okay, this is also a part of review. So in 47, we have 5 divided x plus 2 plus x equals to -8. Okay, this is the rational equation. So we have variable in the denominator, but the way we solve this rational equation and the method we just use for number 2 is going to be very similar. Okay, let's see. So here, now we need to find the common denominator. Okay, so this x has a denominator 1, -8 has a denominator 1. So we have a 3 denominator. X plus 2 is 1 denominator, 1, and the next one is also 1. So what would be the common denominator for these two expression? Can anyone tell me? What do you think? What will be the common denominator here?
Would it just be X because one could be X on the outside and then X plus 2 on the inside, or would we just leave it as X plus 2?
Okay,
Because
now, so every time, okay, let me go back to the one. Okay, now let me, now you need to find the common denominator. So let me start with this 20 and 8. So it's easy number, so we can, we know it's 40, but how, let's see how we find that. So we have a 20 denominator, we have a 8 denominator. Okay, in order to find the common denominator, you take each denominator, okay, and find and write the each denominator in a product form. Okay, prime, so this is a number, so we look for the prime factor. So how can we rewrite 20 as a factor of prime number? So 20 would be 2 times 2 times 5, right? So we have each number, prime number. So 2 times 2, 4 times 5 is 20. So in the similar way, we write 8 in a factor form using a prime number. So this is 2 times 2 times 2. So the common denominator would be, so out of these, so we have uh, this as a factor of a 20 and we have this as a factor of 8. So we look for the common factor. So in these two, we have these two as a common factor. So we write once. So we have another factor 2 as a common. So we write down 1. Just you write down once if it's common. Now we have these two factor which are not common. Okay, so we write these two factors also. So 5, then 2. Now, if you multiply all of this factor, we end up getting 40, and 40 is our common denominator. Now, in the similar way, we have x plus 2. Now, we want to write x plus 2 in a factor form. Now, what would be the factor for x plus 2? You always need to factorize if you can factorize. So how can we rewrite x plus 2 as a factor form? It would be, can anyone help me here? We have x plus 2 and we want to write x plus 2 in a product form, like in a factor form. What do you think? Okay, now we did factorization x time, okay, x time 1, okay, 2 time 1, okay, that's not the one. So that's now here. So we have this algebraic expression x plus 2, okay? So this is, you just take this as a one number, okay? So we don't know x here, x can be any number. So this is a single number and we have to write this number as a product form. And we did a factorization in our review session, okay? So we have those steps, like 3-4 steps to factorize. So if you have an algebraic expression, you have to factorize, okay? Now the first step is that you look for the common term in each, common factor in each term. So we have two terms here, x and positive 2, okay? We don't have any common factor. And we have one, we can rewrite this as a, okay, now let me show you here. So we have x plus 2. So we can look for the common factor in these two terms. So we can rewrite x as a 1 time x plus 1 time 2. Now you see 1 as a common factor. So you factor out 1 and we are left with the x plus 2. So 1 time x plus 2 is a factor. 1 and x plus 2 are a factor for this expression. And the next we have 1, the next denominator. Okay, we have 1 and the factor of 1, we can write 1 as a 1 time 1. Okay, now the common denominator would be, you are looking for the common factor here. Now what do we have as a common? We have 1 as a common. So you write down once. You just write down these two factors just one time. Now we don't have any more common, but we have x plus 2 and 1 left. So you can write those factor as well as x plus 2 time 1. And so this is 1 time x plus 2 time 1 is x plus 2. And this is your common factor, common denominator. Now we use this common denominator to multiply each term of this equation. Okay, you have to multiply every term here. Okay, so x plus 2 time x plus 2 time x plus 2. Since we have more than one term, so this is a binomial, and if you have a binomial or like a more than one term, make sure your terms are inside the parentheses. Okay, and if your term is negative, make sure it's inside the parentheses. And now this is x plus 2 time 5 divided x plus 2 plus x time x plus 2 equals to negative 8 times x plus 2. Now this is the key step here. Okay, now does anyone have any question for this part? Fine, you should be able to find the common denominator. Once you find the common denominator, you use that common denominator to multiply every term of that rational equation. Does anyone have any question here? Okay, now let's simplify. So we have this, what happens to, okay, to x. Oh, so if you're talking about this x divided by 1, so x divided by 1 is x, right? I mean, it's okay, you can still write 1 as your denominator, but you are not required to write 1 every time, okay? But like whenever we divide any number by 1, we end up getting that same number. So you can ignore or you can still write down. Now let's simplify this here. So here we have this x plus 2 factor and we have this x plus 2 factor. So 1 is in the numerator and the other is in the denominator. Okay, so here this is our numerator. Okay, and our numerator is in a factor form. Now I see most of you confused here. So let me rewrite this way. So I have x plus 2 times 5 divided by x plus 2. Okay, so our numerator is in a factor form. Okay, and our denominator is also in a factor form. Like I can add times 1 here. And if you have your numerator and denominator in a factor form, you can cancel the common factor from numerator and denominator. Okay, it has to be, your numerator has to be in a factor form and your denominator has to be in a factor form. Then only you can cancel this common factor. Okay, there might be a case. Okay, for example, you might see x plus 2 plus 5 divided by x plus 2. Now here, can we cancel x plus 2 like we did earlier here?
No.
We can't. Okay, every time if you are canceling numerator and denominator, it has to be in a factor form. Now let's check we have our numerator in a factor form or not. Now factor form means it has to be in a product form. So we have a x, and in between x and 2 we have a positive sign, but we want a multiplication, but here positive. In between 2 and 5 we have positive. Okay, so this x, 2 and 5 are not in a product form. In the similar way, we have x here and we have 2 here. In between these two, we have positive. X and 2 are not in a factor form, so we can't cancel. Now, instead of that, if we had something like x times 2 times 5 divided by x times 2. So here, our numerator is in a factor form, denominator is in a factor form. If you see a common factor, you can cancel. Okay, so make sure while you cancel your uh, factor, it has to be in a factor form. Okay, numerator, denominator, it has to be in a factor form if you want to cancel from numerator and denominator. Okay, now that's what we have here. So x plus 2, this is one factor, and the other factor is 5. In between x plus 2 and 5 we have a product here. In the numerator denominator we have x plus 2, and we can rewrite, we can add 1 time. So this is also in a factor of product form, so we cancel x plus 2 and x plus 2. So after that we are left with positive 5 plus we have x time binomial, so you distribute this x for both terms. X times x square, x times positive 2x equals to, we have negative 8 times. Okay, so you must distribute negative 8 to positive x and positive 2. Negative 8 times positive x, negative 8x, negative 8 times positive 2, that is negative 16. This is an equation. Okay, and this is the quadratic equation. Okay, and we'll be back to this quadratic equation. Okay, let me go back to next number 3. Okay, does anyone have any question up to here? And so here, just let me add, like I also find some of you, like, so whenever you are asked to do, okay, I think it was a complex number, 2i plus 5i, and you have a negative here, and I plus 4. Now here, in this case, you don't use a FOIL here. Okay, so you have a 2 term here, you have a 2 term here, but in between this binomial we have a negative here, so you are not using FOIL. Okay, instead of negative, if it was a product, then you are using FOIL, you are distributing. Okay, so instead of product we have a negative here, so you don't use FOIL here, so this is 2 minus 5i. Now you are distributing this negative for each term in this inside this parenthesis. So negative times I, negative times positive 4, that is negative 4. Okay, so it's not that whenever you see binomial and binomial you are using FOIL. You must have a product sign in between those binomials. Okay, now let me go to the next is number 5. And in number 5, we have 2 times x minus 1 equals to y minus 7. And you had this question on your quiz too. And you are asked to solve this equation for y. Okay, you are solving this equation for y. Some of you even solved this equation for x. Some of you took x as a 0 and you substitute x equals to 0 and you found the value of y. That's not what you are doing. You are solving means now we are solving this equation for y. It means you are making y by itself in one side and the remaining terms on the other side. Okay, so we have negative 7 with y, so we need to get rid of this negative 7. So you add 7 on both sides. You can distribute, you can always simplify here. 2 times x 2x, 2 times negative 1 negative 2, positive 7 equals to this is 0 y. So we have like terms here. 2x plus 5 equals to y. Now we have y by itself on the right side and the remaining terms are on the other side. And this is the solution for y. Okay, so every time if you are solving means you are collecting that variable by itself in one side. You can't have any term there, only that specific variable you are asked to solve. Okay, any question for this part? Okay, now let's go to the number 6 if we don't have any question. So in number 6, okay, this is the application for the simple interest rate here. So a 2800 loan is paid back in 3 years with a simple interest. Okay, so some of you took a loan of 2800, okay, and you paid that $2800 after 3 years, okay. If the amount paid back was $3,388, you took a loan of $2800 from a bank, okay. You took a loan of this amount and you return this loan in 3 years. It means the time you took to pay back is 3 years, and after 3 years the amount you paid back, it was $3,388. You took $2,800. Okay, you use that $28 for 3 years, and after 3 years you paid $3,388. Now what is this $3,388? Is this the interest that you paid for this amount? How many of you think this is the interest for this 2,800? Is this the interest that you paid? No, right? So this is not the interest you paid. So this is the loan amount. We call it principal. Okay, so this is our P. Okay, so this is our P. 2,800 is your loan amount, and after 3 years, the total amount you paid was 3,388, and this total amount include the principal and interest. Okay, so you have to find the interest, and the interest is the difference of this amount and a principal. So 3,388 minus 2,800. So this gives us 28. Okay, is it like 508? Okay, let me see. So 3,388 minus 2,800. So we have 588. So this is your interest, okay? And we know our interest is equals to principal times time and rate, okay? And we are asked to find the simple interest rate. So we are asked to find this R. So you substitute here the values that you are given to you. Our I is given as 588 equals to principal is given as 2,800 in time is given as a 3 year, and a rate which we are required to solve. Now this is 588 2800 times 3. So 2800 times 3, that is 8400 times R. Okay. Now in between R and 8400, we have a product. So in order to get rid of this number, we have to divide by that number on a both side. So this number cancels. Now you see why we were able to cancel. We have 8400 times R. Okay, in the denominator, we have 8400 times 1. So we have a product form in the numerator and denominator. So we can cancel this number. Okay. And on the left side, 588 divided by 8400, that is 0.07 equals to R. And you can write R in terms of percentage. For that, you multiply by 100%, and we get 7% as our simple interest. Okay. Now, does anyone have any question here? So most of you were confused with this amount. Okay, so you should be able to identify what is given to you clearly. Okay, so this 3,388, this is not the simple interest, this is the amount, and this amount include your principal and the interest. To find the interest, you find the difference of amount and principal. Okay, so the interest is amount paid back minus principal. Okay, this is how you can find the interest. Okay, let me know if you have any question up to number 6. And we are done with section 1.1. Okay, so these are the 3 type of question you need to prepare for your exam 1. So 1, solving linear equation. 2nd, solving for some variable. We solve for y here. And the next, there will be a problem related to the simple interest. Okay. Okay, if you don't have any question, now I'll go to number 7, 8, and 9. Okay, so in number 7, we have this equation, x squared minus 9 equals to 0. This is our quadratic equation because the degree is the highest degree for this expression is 2. Okay, if the highest degree is 2, we have a quadratic equation. Okay, and the quadratic equation has at least 2 solutions, and it does mention the instruction is very clear. It tells us to solve the equation by factoring. Okay, now I think you might have seen I graded your quiz, and I found most of students using the quadratic formula here. No, you are asked to use factoring. You have to use factoring. Okay, if you are asked to use completing square method, you have to use that specific method. Now, if it does not tell you what methods to use, then you are free to pick your best method. Okay, for number 7, you are asked to use factoring, and you have to use factoring. You won't get credit, even if you won't get partial credit, okay, if you use the different method. Okay, now here, and whenever you are solving the quadratic equation by factoring, the first step is you are writing your quadratic equation in a standard form. So standard form looks like this: ax squared plus bx plus c equals to 0. So you have 0 in one side of the equation. Okay, so every time if you are using a factoring method and a quadratic formula, this is the first step. You are making 0 in one side, and that's what we already have, so we can skip that. The next step, we factorize whatever we have on the left side. Okay, now how do we factorize x squared minus 9? The first step, do we have a common factor in these two terms? That's the first question you have to ask yourself. Do we, other than 1, do we have any common factor in x squared and negative 9? We do have 1 as a common factor, but you can ignore that. Other than 1, we don't have any common factor. Now the next step of factorization is that now we check how many terms we have. So we have 2 terms here. Okay, now is that 2 terms difference of 2 square term? Is that 2 term difference of cubic term is that two terms sum of cubic term. So you have these three options if you have two terms. Is those two terms the difference of two perfect square term, or that two terms can be the difference of two cubic terms, or it can be sum of two cubic terms. Okay, now if you have a difference of two square term, so the factor would look like a plus b times a minus b. Okay, if you have a difference of cubic term, the factor would be a minus b times a square plus ab plus b square. And if you have a sum of cubic terms, the factors will be a plus b times a square minus ab plus b square. And for this exam, I think I'm pretty sure you don't have these two expression. Okay, you don't have the binomial difference of two cubic terms and a sum of two cubic terms, but you might see the difference of a square term. Okay, so you should know how to factorize this here. Okay, so we know this is the difference of two square term, and we can rewrite that. So this is x square minus, we can write 9 as a 3 square equals to 2. So we have a difference of 2 square term. So if this is the case, the factor would be you take x plus 3 times x minus 3. X minus 3 equals to 0. This is how we factorize if you have a difference of two perfect square terms. Does anyone have any question in factorization here? Okay, now once you write down your left side, okay, so can I see the examples again? Factoring, do you mean more examples, or okay, so this is the type of expression you might see on your exam. Okay, so you can ignore these two for now. Okay, now once you have your left side in a factor form, you set each factor equals to 0. So you write down first factor, x plus 3 equals to 0. You write down second factor, x minus 3 equals to 0. And I found some of you left your answer up to here. You had up to here as your final answer. No, this is not. Okay, you are asked to solve. Okay, solving means you are finding the value of variable. Okay, so this is not the value of variable, so don't forget this equals to here 0. And once you have the factor, you take each factor and set it equals to 0. You take second factor, set it equals to 0. Now we have this linear equation, so you subtract 3 on both sides, and for this equation you add 3 on both sides. This is 0, x equals to negative 3. This is 0, x equals to positive 3. And these are the solution for this quadratic equation. Okay, let me know if you have any question. Okay, now number 9 is, it's a number 8 is very similar. Okay, so this is 2x squared minus 8 equals to 0, and I want you to practice by yourself. Okay, and if you need help, yeah, just let me know. So I will skip this and I will go to number 9. So in number 9, we have x squared minus 9x plus 20 equals to 0. We are still solving the equation by factoring method. Okay, so here the first step is having 0 in one side. We already have 0, so let's go to the next step, factoring the left side. So we have to factorize this trinomial. We have 3 terms. Okay, and this 3 term is in a quadratic form. Okay, and also this quadratic form has a coefficient of this square term as a 1. Okay, so if you have a quadratic expression with the coefficient of square term as a 1, then the method we use for factorization is, what method do we use here? Do you recall? We have a quadratic form, the coefficient of square term is 1. And if that is the case, what method do we use to factorize here? Anyone? Can you guess what method we will be using here to factorize this quadratic form with a coefficient of square term 1? You can still use AC method, but we do have easier than AC method. So instead of AC method, we use FOIL, okay? So if the coefficient is 1, so it has to be in a quadratic form and the coefficient of the square term has to be 1, then we use FOIL. That is, you can get the factor in one line. Okay, so this is, we get the two factor, okay? Now we look for the first term here whose product is x squared. Now can you think of two terms, two first terms whose product will be x squared? What will be those two terms? It has to be x and x, right? X times x is x squared. And the next here, we need to find two number. Let me call these two number are p and q, okay? So we need to find a two number whose product has to be this constant. So when you multiply p and q, the product has to be positive 20. And when you add these two numbers, that sum has to be the coefficient of x, which is negative 9. So when you are adding p and q, the sum has to be negative 9. Now think of two numbers whose product is 20, positive 20, and the sum of those same two numbers is negative 9. Okay, give me those two numbers. Negative 5 and 4. Okay, let's try. So negative 5 times 4 is negative 20. No, we want positive 20. So this is not, these are not the correct numbers. Give me a two number whose product is, yes, is negative 5, negative 4. So negative 5 times negative 4 is positive 20. Negative 5 plus negative 4 is negative 9. So our P and Q are negative 5, negative 4. Okay, equals to 0. So we are done with the factorization. Now, once we have the factor, you take each factor and set it equals to 0. You take second factor, set it equals to 0. Now this is a linear equation. We know how to solve. You add 5 here, you add 4 here. This is 0, x equals to 5. This is 0, x equals to 4. And these are the solution for this quadratic equation. Okay, if you have any question, let me know. Good. Now let's go to the next one. We have number 12, negative 6x squared, negative 5x positive 4 equals to 0. We are still using the factoring method. And the first step of using factoring method is we are making 0 in one side. We already have 0 on the right side. So we can skip this step. We look for the next step is factoring whatever we have on the left side. So on the left side, we have quadratic form and the coefficient of square term is other than 1. Now, if this is the case, we use AC method. Okay. So if you have a quadratic form and the coefficient of square term is not 1, then we use AC method. Now in the AC method, okay, let me rewrite this again. 6x squared negative 5x positive 4 equals to 0. So this is our A, the coefficient of x is B, and the constant is C. So in the AC method, we multiply A and C. So we have 6, 4. You can ignore sign or you can take sign. Okay, it really doesn't matter. So our A is 6, B, C is 4. You multiply these two, we get 24. Okay, next step is we write down each pair of factor of 24. Okay, so let's start from 1. So 1 is a factor of 24. So 1 divided by 24 is 24. So 1 and 24. This is okay. Addition. Okay, what is the question, addition?
Sorry, to go back again, may you re explain again why are we using the AC method and not FOIL again, please? I'm sorry.
Okay. Now, so you can still use a FOIL here. Okay, so you can always use a FOIL and AC method for all quadratic form. But if you have a coefficient of a square term as a 1, FOIL is more easier. Okay, so we always use FOIL if the coefficient of a square term is 1. Now, in this equation, the coefficient of a square term is not 1, it is negative 6. So if the coefficient of a square term is not 1 or negative 1, then I always want you to use the AC method. You can still use FOIL method, but there is a high chance that you're going to make an error. So always use AC method if the coefficient of a square term is not 1 or negative 1. Okay,
Okay, thank you.
all right. So here we multiply A and C. Once you get the product, you write down every pair of factor for this number starting from 1. So you start with 1, divide this number. 1 divided by 24, we get 24. The next number is 2. 2 divided by 24 is 12, right? 2 and 12 is another pair. Then 3 and 8, 4 and 6. So these are the pair of factors for 20. Now, out of this pair of factors of 24, we pick one pair of factor to rewrite our b, which is negative. Okay, so we use one pair of factor out of this here to rewrite our middle term, which is negative 5x. Okay, now in order to rewrite, you can add these two number. Okay, you can add this pair of factor or you can subtract pair of factors. Now what pair of factor out of these four we can use to rewrite negative 5x? You can start from first one. So we have 1 and 24. If we add 1 and 24, we get 25. If you subtract 1 and 24, we get 23. That's not what you want. We want a negative 5. So this is not the one. So let's do this one. 2 plus 12, 14. 2 minus 12, 10. That's not what we want. Now we have 3 plus 8, 11. But 3 minus 8, that's negative 5. That's what you want. So we will pick this number 3 and 8 to rewrite this middle term. So here negative 6x squared. Now how can we rewrite negative 5x using 3 and 8? So how do we rewrite negative? You are rewriting negative 5x, okay, using the coefficient 3 and 8. How do you do that?
For clarification, Professor,
Mhm,
I'm trying to follow, but when we did 6 times 4 for the AC method and we got 24, why
mhm.
did you do positive 6 instead of negative 6?
Okay, now it doesn't, you can take a negative. Okay, it's nothing wrong, you can still take a negative. You get negative 24, right? So you will have negative 1 times positive 24, negative 2 times positive 12, and if you take negative 3 it will be positive 8. If you take negative 4 it will be positive. It really doesn't matter. Okay, you can still take a negative, so you can ignore sign or you can take it. Okay,
Okay, thank you.
it doesn't matter. Now we have 3 and 8. We are rewriting negative 5x using a coefficient 3 and 8. And how do we do that? What is negative 5x? How do you
Would it
rewrite?
be plus 3x minus 8x?
So did you say, can you repeat that?
Would it be negative 6x squared plus 3x minus 8x plus 4?
3x minus 8x plus 4. Now let's check it. Now, is this two term equal to negative 5x? 3x minus 8x is negative 5x, right? That's correct. So you are rewriting. So you are not adding any new terms here. So you are rewriting this negative 5x in two different terms. Okay, so that's correct. And this is equals to 0. Don't forget this. Now, We have to factorize. We are trying to factorize. Now we have four terms. And if we have a four terms, we make a pair. So let's make a pair of first two term and last two terms. Now in the first two terms, we look for the common factor. So what will be the common factor here? Now we have a negative for this first term. So you can take negative 3 is also common factor, and we also have x on a both. So negative 3x as a common factor. If you factor out negative 3x from negative 6x squared, what do we have here? So you are factoring out negative 3x from negative 6x squared. How do we find what to write here? You divide this term by your common factor. Negative 6x squared divided by negative 3x is 6 divided by negative 6 divided by negative 3 is positive 2. X squared divided by x is x. Okay, then you have this term, and if you factor out negative 3x from positive 3x, you divide positive 3x by negative 3x, we end up getting negative 1. Now in these last two terms, so we have negative for this first term, so you can take negative as a common factor, and the next we have 4, okay, as a common factor. So if you factor out negative 4 from negative 8x, so negative 8x divided by negative 4 is positive 2x. If you factor out negative 4 from positive 4, so positive 4 divided by negative 4, that is negative 1 equals to 0. Okay, does anyone have question here? Okay, now, so we have 2x minus 1 as a common factor because see, we have a product form. Okay, so this is common. So let's factor out. So 2x minus 1 is a common. So we have negative 3x here, and we have negative 4 left equals to 0. So we factor completely. Now, once you have complete factorization in one side, you take each factor and set it equals to 0. So you take 2x minus 1, then set it equals to 0. You take the next factor, negative 3x minus 4, set it equals to 0. Now these are linear equation. We are solving linear equation. We add 1 here on the both side. You add 4 on the both side. So we have 2x, this is 0 equals to 1. This is 0, negative 3x equals to 4. To get rid of 2, you divide by 2 on both sides. To get rid of negative 3, you divide both sides by negative 3. This 2 and 2 cancel. We have x equals to 1 half. This negative 3 cancel. We have x equals to negative 4 over 3. And these are the solution for this quadratic equation. And I think this is what you have on your had on your quiz too as well. Okay, any question here? Okay, let me go to the next one.
So question.
Yes.
Sorry, Professor. Alonso was asking in the group chat. He says, does it matter if he wrote negative 8x plus 3x rather than us doing the negative?
No, it doesn't matter. Now, isn't this same like negative 8x plus 3x is also 5x, and positive 3x minus 8x is also negative 5x. It's the same thing. So you can write like this, like if a plus b is same as b plus a, right? 4 plus 3 is also 7. 3 plus 4 is also 7. So it's correct. You can use any form here. Any more? Okay, so let me go to the next one. So this is number 12. So 13, 15, 16. Okay, so we have 13, 15, and 16. So in 13, excuse me, 15 and 16, you are asked to use completing square method. And you will have one question. Okay, I know this is not easy. Most of you may not feel comfortable with this example. But you will have one problem on your exam one where you will be asked to use completing square method. So number 13. So we have x square minus 4x minus 2 equals to 0. Okay. So every time if you are solving this equation using a completing square method, the first step is you are collecting every terms with a variable. So we have variable here, we have variable here. So you are collecting these terms in one side of the equation, and the constant, -2 is a constant, this constant on the other side. So let's add 2 so that we can get rid of constant from left side. So this gives us x square minus 4x equals to 2. Okay, this is your first step. You are writing every term with a variable in one side and a constant on the other side. Second step, you are making the coefficient of square term. So this is our square term. Square term means it's a term with exponent 2. You are making the coefficient of a square term equals to 1. And that's what we have here. See, this x square term has a coefficient 1. It's already 1, so we can skip this step. Okay. And I will do one more example where the coefficient is not equals to 1. Okay, so that is our second step, making the coefficient of a square term equals to 1. In this case, we already have 1, so we can skip that step. The next third step is you take the coefficient of this coefficient of x term. Okay, you take the coefficient of x term. You can ignore sign, okay, forget about sign. Then you divide by 2. So 4 divided by 2, we get 2. You will square that number, and you are using this expression to add on both sides of the equation. Okay, you take the coefficient of x, forget about sign, you take the coefficient of x, which is 4. For every coefficient, you divide by 2. 4 divided by 2, we get 2. You square that number, we get 2 square. We are using this number, okay, you are adding this number on both side of the equation. Okay, so our equation become x square minus 4x. We added 2 square on both sides, so we have 2 plus 2 square. And it depends, okay, so it's not always 2 square. So the number that we are adding on both sides, it depends on the coefficient of x term. So if the coefficient of x term is 10, then you are dividing 10 by 2, we get 5, and you square it. You are adding 5 square on both sides. Okay, sometime the coefficient might be 3, divide by 2. You square this number, and you are adding 3 over 2 square on both sides of the equation. Now, so we have this 3 term on the left side. We can rewrite this 3 term as a square of a binomial. Okay, to rewrite that, you take x from the first square term, you take 2 from the last square term, and in between these two terms, we take the sign of middle term. We have negative, so you have negative here, and parenthesis inside the parenthesis, and you have a square here. So these 3 terms is same as this square of these 2 terms. Their form is different, but they are exactly same. Okay, so whenever you have this expression, you can rewrite as a square of a binomial. On the right side, we have 2 plus 2 square 4, which is 6. So this is x minus 2 square equals to 6. Okay, now we use square root principle. Okay, we have a square here, we need to get rid of this square, so that make this equation as x minus 2 equals to, whenever you get rid of this square, you end up getting radical square root on our right side. You end up getting positive or negative square root. Okay, and whatever you have on the right side is under the square root. So we have -2 here. Let's get rid of -2. We add 2 on both sides. This is gone. x equals to positive negative square root of 6 plus 2. Now we have positive square root 6 and negative square root of 6. So let's take positive square root of 6 and the remaining. So we have square root of 6 plus 2. Now let's take negative sign and the remaining expression. We have negative square root of 6 plus 2. And these are the solution for this quadratic equation. Okay, any question here?
Do you have a preference on having it written out that way? I can't, for example, like if I were to write my answer as x equals plus minus on top of each other.
This is correct.
Okay, you'll accept it. Okay.
Okay, I just want to show that here are the two solutions. Okay, so if you want to use this one or this one, both of them are correct. Okay, does anyone have any question here? And I will do one more. Okay, so for your practice, there is 13, 15, and 16. I want you to practice 15, and I will do number 16 here. So number 16, we have negative 2x squared plus 8x equals to 1. We are solving this quadratic equation using the completing square method. The first step is we write every term with variable in one side and the constant on the other side, which we already have here. So we can skip that. Let's go to the second step. Second step is making the coefficient of a square term. So this is our square term. So this is our square term, and we want to make the coefficient of this square term as a 1. Right now, we have negative 2 as a coefficient, and we want to make it positive 1. Now, how do we make the coefficient of this square term as a positive 1? What do we need to do? Do we add, subtract, multiply, divide? What do you think?
Do you divide each term by -2?
That's right. So make sure you are dividing every term in this equation. Okay, so you are dividing every term by -2. -2. Now let's simplify. Negative 2x squared divided by -2 is positive x squared. Positive 8x divided by -2 is negative 4x equals to negative half. Now the next step is we take the coefficient of x. Okay, we have 4. You divide the coefficient by 2. We get 2. You square it, and you are adding these two numbers on a both side of the equation. So this is, let me rewrite, x squared minus 4x plus 2 squared equals to negative half plus 2 squared. Now we have these three terms. We write these three terms as a square of a binomial. So you take the x from here for the first term in your binomial. You take 2 from the last perfect square term, and the sign would be the sign of middle term, which is negative, and parenthesis square equals to, so we have negative half plus 4. Let's simplify on the right side. We need to have a common denominator, so it has 2. So let's make the denominator of this 4 2. We have 1, and to make it 2, you multiply by 2 in the numerator and denominator. So this is 1/2 plus 4 times 2, 8 divided by 2. This is 7 divided by 2. Negative 1 plus 8 is 7, and we have 2. So this is x, sorry, it's minus. And this, you had this question on a quiz too, and some of you, I think, yes, some of you didn't get it correct here. Okay, now use the square root principle. It means you get rid of this square. So we write whatever we have inside the parentheses. Sorry, this is -2 equals, and when you get rid of this square, you have positive negative square root, and whatever you have on the right side will be under the square root. Now we have -2 on the left. We need to get rid of that. So you add a 2 on both sides. So this is gone. So we have x equals to positive negative square root 7 over 2 plus 2. And I will take this as your final answer. There is still way to simplify, but this is fine. Okay, now do you have any question here? As I said, you will have one question where you have to use this method. You will be asked to use factorization, you will be asked to use completing square method, you will be also asked to use quadratic formula. Okay, looks like none of you have a question here. The next is, so we did 13, 15, 16. Okay, let's see what we have, 17 and 20. Okay, is it okay if I skip 17 and 20? This is solving the quadratic equation using a quadratic formula, and almost like every one of you has this correct. Now, does anyone need help with this quadratic formula? Or is it okay if I skip this now? Does anyone need help in solving the equation using quadratic formula? Okay, so I will skip this. Okay, and if you need help and we still have time, your exam is due, you will have your exam available from tomorrow and due until Monday midnight. So if you have a question or if you need help, let me know. So I will skip this to 17 and 20. Now the next, we have 33, 35. Okay, 33, 35. Okay, now we are done with section 1.2. Now we are at section 1.3. So 33 and 35. Okay, out of 33 and 35, let me pick one. Which one do you want me to do? It's very similar. Do you want me to do number 33 or 35?
35.
Okay, let's do 35. So 35, we have complex number. They use x to represent that complex number. We have negative root 2 plus I, and the next complex number they use here y to represent, oh, this is not a complex number, this is a real number. Okay, so here we have this complex number and they use x to represent that complex number. Okay, this is one number, this is one complex number, and we have a real number negative 3 and they use y to represent negative 3. This is a complex number. Complex number always has I, okay, imaginary part and the real part. So this is the real part. Negative root 2 is the real part, and the part with I is the imaginary part. Now we are asked to find here x plus y. You are asked to find x minus y. You are asked to find x times y. You are asked to find x divided y. Okay, now, what sign do we have in between x and y here? We have a plus, right? It means we are adding these two complex number. So let's find x plus y. So what do we know about our x? Our x is negative root 2 plus I. Positive. What do we know about our y? Which is negative 3. Now, if you have a negative number or more than one term, make sure you are using parentheses. Now, let's simplify. Simplify means you are looking for the like terms. Now, so we have, let's get rid of this parenthesis here first. So negative root 2 plus I positive times, so this is time here, times negative 3 is negative 3. Now, so this is also these two are a real part. So we write down them together, or you can simplify using calculator, or you can write negative 2 and negative 3 together and I separately, and this is your final answer. And you can use your calculator and write the decimal here, but you are not required to do that. Does anyone have any question in finding x plus y? You are adding x complex number and y complex number. Okay, now let's find x minus y. X minus y. Now we have a negative difference. So we are finding the difference between x complex number and y complex number. So let's substitute our x. X is negative square root of 2 plus I. Now we have a negative here. Now what about our y? Y is negative 3. It's a negative number, so make sure it's inside parentheses. So this is negative root 2. I'm copying this one, plus I. Negative times negative 3 is positive 3. Now we have this number and this number as a real part. So let's write them together. So negative root 2 plus 3 and I separate. And this is the difference of these two complex number. Let me know if you have any questions. Okay, now the next we are asked to find the x time y. X time y. You substitute your x. What is our x? Negative root 2 plus I. Now we are multiplying and we have a two term here. So let me keep this inside the parenthesis. Time. So we have times here times y. Our y is negative 3 inside the parenthesis. Okay. Now you are multiplying here. Okay. Now if you compare these two, okay, I still find some of you confused here. So okay, so here and here. So here we have a positive. Okay, now here we have a product. So when we have a product, we have to distribute, but here you don't need to distribute here. Now you distribute negative 3 to negative root 2 and you distribute negative 3 to positive I. So negative, okay, let me write down this negative root 2 times negative 3, okay, positive I times negative 3. Negative times negative, we get positive. Okay, and we don't need to write positive, so we understand it. And 3 times root 2 is so this radical expression, okay, it has a, so you know to multiply this, so we have 3. So we have you can always imagine 1 in front of radical number. Okay, we always have 1 here. So negative 1 times negative 3, that is positive 3, and we have root 2 as it is, plus I times negative 3 is negative 3I. And this is a product of these two complex numbers. Does anyone have any question? Okay. The next we have x divided by y. So you divide x complex number, which is negative 2 plus I, and you divide this by y, which is negative 3. Now, I think I will do one more of this division. Okay. Now here, so whenever you are dividing, you don't want your complex number in the denominator. Now we don't have complex number in the denominator, so this is your final answer. Okay, and you can rewrite. You can separate this as a negative root 2 divided by negative 3 plus I divided by negative 3. So this is negative negative cancel. We have root 2 divided by 3. Positive times negative, negative I over 3. Or you can just leave it here. It's correct. But what if you have I or a complex number in the denominator? Like if you choose, so like 33, if we are finding x over y. So for number 33, our x is 3 plus 2I, and our y is negative 4 plus 3I. Now, here we have a complex number in the denominator, okay? And we don't want complex number in the denominator. We want to have a real number, okay? So dividing by a complex number means you are getting rid of complex number from the denominator. Okay, and the only way to get rid of complex number is multiplying that complex number by its conjugate. Okay, every time if you multiply a complex number by its conjugate, we always end up getting real number. So here we have this denominator complex number. We want to rewrite this complex number in terms of real. Okay, so for that we multiply numerator and denominator by the conjugate of this. And how do we write the conjugate? We switch the sign of imaginary part. So we have -4 as it is. The imaginary part is positive, so we write down -3i and use the same complex number in the denominator. Now, does anyone have a question here? Okay, now so we have a fraction times fraction. So you multiply numerator together and denominator together. So this is 3 plus 2i. We have more than one term. So parentheses times. So this time -4 times -3i divided -4 plus 3i times -4 minus 3i. You use the FOIL here. So we have a one term, two term here. We have a two term, two term, two term. So you can use FOIL. So first term times first term. 3 times -4, -12. Okay, then you can multiply first term and last term, or like whatever the order really doesn't matter. So 3 times -3i, -9i, 2i times -4, -8i, 2i times -3i, that is -6i times I square. In the denominator, use the same method. 4 times, sorry, -4 times -4, positive 16, -4 times -3i, positive 12i, positive 3i times -4, -12i, positive 3i times -3i, -3 times 3, 9i times I square. So this 2 is 0. Now we simplify, look for the like terms. So this is, okay, now -12 as it is. So these two are like terms. -9i, -8i, that is -17i minus 6. What do we know about I square? I square is always equals to -1, right? So if you have I square, you have to rewrite that using -1. Okay, so we have -6, we have times here, times -1. 16, so we have -9. This I square is -1, so 9 times -1. So let me simplify one more time. -12, -17i, -6 times -1, positive 6, divided 16, -9 times -1, that is positive 9. So this is like terms, -12, positive 6, -6 minus 17i, this is 25. You can separate the real part and imaginary part. So you break it down into two fractions. -6 divided by 25, -17i divided by 25, and this is x divided by y. Okay, let me know if you have any question here. Okay, now let's go to the next here. Okay, what, so this was 33, 35. Okay, now 42, 44. Okay, now we are at, okay, okay, it looks long here, but if there is any way we could skip some of the simple step, you can skip it. Okay, yeah, it's a practice. I think once you practice few more, I think you can skip. I try to include every step here, but like during your exam time, you have a 90 minutes. Okay, I'm pretty sure you will have that enough time, and you can skip some of the simple step. Okay. Okay, now let's go to 42 and 44. Okay, this is next section 1.4. So we have 42 and 44. Okay, 42 and 44 are very much similar, and I will do one out of these two. Okay, pick which one do you want me to do? 42 or 44? Does anyone have any preference here?
44, please.
Okay, let me do 44. So we have negative 3x to the power 4 plus 11x squared equals to negative 4. And the question tells find all real solutions of this polynomial equation. Okay, finding real solution means we are finding or we are solving this equation for our variable x. Okay, now this is a special type of equation with a degree 4 here. Okay, and if you have a equation with a degree 4, there is a common method of solving this equation. Okay, now that method is, so we rewrite this equation as, let me make it 0 on the right side first. Okay, so for that we add 4 on both side. So this is negative 3x to the power 4 plus 11x square plus 4 equals to 0. Now we will rewrite this x to the power 4 in terms of square term. Now, can we rewrite x to the power 4 as a x square to the power 2? Do you agree here? So if you have a polynomial equation with a degree 4, then you will rewrite the x to the power 4 as a square of a x square. Okay, these two are the same thing. Plus 11x squared plus 4 equals to 0. Now we make a substitution here. So for every x square, we substitute some different variable. You can pick any variable, whatever you want. Let me use a. So for every x square, I will substitute a. So this make my equation as a negative 3 for x square. We are using a and we still have this square. Okay, plus 11 for this x square. We are using a plus 4 equals to 0. Now, what is the type of equation here? What type of equation do you see here? Now, this equation is quadratic equation. And we know how to solve quadratic equation. Now, you can pick any method here. Factorization, completing square, or a quadratic formula. Okay, you can use any method here. So which method do you, okay, now let me use quadratic formula here. Okay, because we didn't do earlier. So our variable is a, so a equals to what is the formula? Negative b plus minus b square minus 4ac divided by 2a. So this is the one formula you will be given on your exam, and the next formula you will be provided on your exam is I equals to PTR. I think remaining, I don't, okay, I think these are the only two formulas you will be provided. Okay, so we don't have more formulas there. Okay, now let me use quadratic formula. This is our a, right? The coefficient of square term is a. The coefficient of a term with a degree power 1 is b, so this is b, positive 11, and this constant is c. So negative, so we have negative as it is, b is 11 plus minus b square, 11 square minus 4 times a is negative 3, make sure parenthesis for negative number, and c is 4, divided by 2 times a is negative 3, parenthesis. Okay, so this is negative 11 plus minus, okay, so this is 11 square is 121. Now if it was negative, if your b was negative 11, what would be b square? Okay, for example, if your b is negative 11, what would be b square equals to? Some of you have had a not some, most of you had some mistake here. So for example, if b is negative 11, what would be b square? What do you think here? Is it positive 121 or negative 121?
Positive 121.
That's right. Okay, so here, so you have to square this negative as well as this number 11. So negative times negative, you get positive. 11 times 11, you get 121. Okay, not negative. most of you have a negative there, so make sure this is a very minor, but you have to be very careful. Okay, so negative 4 times negative 3, positive 12 times 4, that is positive 48. Yes, divided by 2 times negative 3, that is negative 6. So negative 11 plus minus, okay, 121 plus 48, that's 9 6 1, okay, 169 divided by negative 6, plus minus, this is square root of 169, it's 13 divided by negative 6. Now let me take positive sign, so that make expression negative 11 plus 13 divided by negative 6, comma, let me take negative sign, so everything remains same. Okay, you are only taking a positive once and negative other time, so negative 13 divided by negative 6. Simplify negative 11 plus 13, that is positive 2 divided by minus 6, that is a negative 24 divided by minus 6, this is minus 1 over 3, this is positive 4. Okay, so these are the solution for A. Okay, now if we scroll, okay, now here, so this is the values for A, but the question we are asked is to solve the equation for X. We are solving the equation for X. Okay, so we are not done it. But what do we know about A? Our A is X square, right? So you replace A by X square equals to negative 1 over 3 and 4. So let's take X square equals to negative 1/3, and let's take X square equals to positive 4. So we have two equations here. Now using square root principle, so we have X equals to, we get positive negative square root of right side. We have negative 1 over 3, and here X equals to positive negative square root of 4. Now what kind of number is this? Is this a real number? We have a negative under the radical sign. This is not real, this is complex number, or this is imaginary number. Okay, now so don't write your final answer. Okay, like in your final answer, if you have a negative under the radical sign, you have to rewrite this. Okay, we know how to rewrite this, so we can replace this negative by I square 1 over 3 as it is, positive negative, square root of I square is I, square root of 1 is 1, and square root of 3 is square root of 3. On the other side, X equals to positive negative square root of 4 is 2. And these are the four solutions. Okay, the degree is 4 here, the highest exponent is 4. See, we have 4 solutions. So the degree give us the number of solution that we're gonna get. Okay, so we have positive I over root 3, negative I over root 3, positive 2, negative 2. These are the 4 solutions, but we are asked to find only real solution, and these two number are only the real solutions. Okay, this is about 44. Do you have any question for me? I know this is a lot, but if you practice, like from here, the only key step is this one. Like if you have a quadratic form, the remaining is using the quadratic formula which you have practiced earlier. Does anyone have question here? Okay, and I want you to practice 42 by yourself, and if you need help, please let me know. Okay, now 42, 44, okay, now 47, 49. 47, that's what we started earlier, and 49. Okay, now let me go here, 47, that's what we started earlier. Okay. Oh, okay, now this was the part of 47. I think now from here, do you think will you be able to solve this 47 from here? This is the quadratic equation, right? Now, will you be able to solve this equation? I mean, you can use the quadratic formula or factorization or completing square method. Is it okay if I skip from here? Yes, no. You have two options. If you say yes, I will skip. If you say no, I will complete this example. Okay, so all of you are silent. What does that mean? So it means I can skip that. If you are not skipping, I'm okay with it. I'm also okay with that. But I will do one more example of solving a rational equation. Okay, I will solve. I think should be 49. Yes, 49 and 51. Okay. 40. Okay, hold on. Oh, 49, 51. Okay, I will do 49 here. Okay, number 49. So we have 2 divided x square minus positive 3x minus 4 plus 1 over x minus 1 equals to negative 6 divided x plus 4. So this is our rational equation. Okay, in order to solve a rational equation, we have to find the common denominator. To find the common denominator, let's write down all denominator together. So we have these three denominator, x squared plus 3x minus 4. This is 1. X minus 1. This is the next. X plus 4. So we have these three denominator. Now to find the common denominator, we write down each denominator in a factor form. Okay, so we have this quadratic trinomial. We have this quadratic expression with the coefficient of square term 1. Now what method do we use to factorize this type? Who can tell me? What method do we use here? We use FOIL. Okay, so we get 2 factor. Now give me the first term whose product is x squared. What should be the first term whose product is x squared? It is x. Okay, good. Now we look for the 2 number whose product is negative 4 and sum is positive 3. So think of 2 number whose product is negative 4 and sum is positive 3. 2 number whose product is negative 4 and sum is positive 3. The product has to be negative 4, sum has to be positive 3, and that is negative 4 and positive 1. Negative 4 times positive 1 is negative 4, and negative 4 plus 1 is, oh, no, not the negative 4. Positive 4 and negative 1. Okay, positive 4 times negative 1 is negative 4. Positive 4 plus negative 1 is positive 3. Now, x minus 1, this is the already in a simplest form. We can't factorize anymore. So x minus 1 itself is a factor. This is also in the simplest form. So x plus 4 is the factor of itself. So our common denominator would be, now you look for the common factor in all these three denominator. Do we have common factor in all of these three? We don't have any, but we do have a common factor in two denominator. Like we have x plus 4 here, we have x plus 4 here. So we write down 1 time. So x plus 4. Now, do we have any more common? So we have x minus 1 common. So x minus 1 common. Now we don't have any more factor. So this is our common denominator. Now we use this common denominator to multiply every expression. So this expression, this expression, this expression. We use this common denominator to multiply every of this expression. and that is 2 over so let me rewrite x squared plus 3x minus 4 as a this factor form. Okay, x plus 4 times x minus 1. We are multiplying this by the common denominator, x plus 4 x minus 1. Now the second is plus 1 over x minus 1. We are multiplying this by the common denominator, x plus 4 x minus 1. The next expression we have on the right side, negative 6 over x plus 4. We are multiplying by the common denominator, x plus 4 times x minus 1. Okay, now so here, so this x plus 4 common, x minus 1 common, so they cancel, x minus 1 common, cancel, x plus 4 common, cancel. So the remaining we have 2, so nothing left, plus 1 times x plus 4 equals to negative 6 times x minus 1. So everything gone. So we have 2 plus 4 like terms, so that is 6 plus x equals to, you distribute this, negative 6 times x, negative 6x, negative 6 times negative 1, positive 6. Now this is a linear equation. We all know how to solve. So you subtract 6 on both sides. Okay, this is gone. X equals to negative 6x plus, oh, that is 0. Now let's collect x together. So we add 6x on both sides. This gives us 7x equals to, this is 0. We need to get rid of 7, divided by 7, x equals to 0. This is the solution for this rational equation. Okay, let me know if you have any question here. And there will be one rational equation, okay, to solve for you. And I want you to practice, okay? So you can, so don't expect exactly same question. You may get, you may not get. So don't expect exactly same equation, but you should know how to solve these equations. Okay, if you don't have any question, I'm starting next one. So I'm at 51, 53, 54. Okay. So 51, 53. Okay, 51 and 53. These are the radical equation. Which one do you want me to do, 51 or 53? So you have the two options. Both of these are radical equation. Okay, let me pick 50. Okay, 53. So I will do 53. So we have square root 2x plus 3 plus square root x plus 6 equals to 6. Okay, now this is the radical equation with a two radical expression. So we have one here and we have another here. So if we have a equation with a two radical expression, I want you to take one radical expression into the other side. Okay, that will make use easier. Okay, like in 51. So if it was 51, so in 51, we have something like this, square root of 3x plus 4 plus 2 equals to x. We only have one radical expression, okay? So if you have one radical expression, I want you to keep that radical expression in one side and the remaining other side. So it means I want you to take positive 2 to the other side, okay? But if you have a two radical radical expression, so you can take any one of the radical expression to the other side. Okay. So let me take that positive square root of 6 on the other side. For that, I subtract same number on both sides. So this is gone. Square root of 2x plus 3 equals 6 times square root of x plus 6. Okay, now for your exam, Okay, let me change the review here. I want you to practice 50 and 51, not this 52 and 53. Okay, now, okay, I want you to practice 51 and 50. Okay, and I will do one of these two. Right now, let me get rid of, let's not solve this one. Now, the reason here is that uh, it's gonna be too long. Okay, so, and I don't want to scare you. So if you want to practice, so you square here, okay, you simplify, you again get a radical expression, and you again have to square. So this is gonna be a lot here. So I want you to practice 50 and 51. Okay, so let me do 51 for you, and you can do 50 by yourself. Okay, so we have square root of 3x plus 4 plus 2 equals to x. So practice the radical equation with only one radical expression, okay, like 51. So here we have this expression, radical expression, only one. So if you have only one radical expression, you write this radical expression in one side and the remaining term on the other side. So let's get rid of negative positive 2. So you subtract 2 on both sides. So this is square root of 3x plus 4 equals to x minus 2. Okay, the next here is getting rid of this radical sign. Okay, this radical sign has an index 2. Okay, it's a square root. Okay, so square means 2. Now, in order to get rid of this square root, we square both each term. Okay, so you square both sides. So you square left side, you square right side. If you have a cube root, you cannot take cube on a both side. If you have a root of power, fourth root, then you're gonna take fourth power on a both side. Okay, that's how we get rid of radical sign. So this is our square root. So we are squaring on a both side. Now this square root and this square, it cancels. So we have 3x plus 4 equals to, now we have x minus 2 is square. So we can rewrite this as x minus 2 times x minus 2. Okay, so this is 3x plus 4. Now here, so this is not equals to x squared minus 4. Okay, so this is wrong. So you have to rewrite this x minus 2 times x minus 2 and use FOIL here. So x times x square, x times negative 2, negative 2x, negative 2 times x, negative 2x, negative 2 times negative 2, positive 4. Now we have a square term, so this is a quadratic equation. So let's make 0 in one side. So subtract 3x on both sides, subtract 4 on both sides. So this is 0, this is 0 on the left. So we have x square, negative 2x, negative 2x, negative 3x. That is negative 7x, positive 4, negative 4, 0. Now we can rewrite this as a x square minus 7x equals to 0. Okay, it's okay if we switch left and right. Now let's use factorization. It's going to be easier. So we look for the common factor. So we have x as a common. So let's factor out x. If you factor out x from x squared, we have x. If you factor out x from 7, negative 7x, we have negative 7 equals to 0. Now, once you have complete factor, you take each factor, set it equals to 0. You take each second factor and set it equals to 0. So you add 7 here and your x is 7 or 0. So these two are the solution for this radical equation. And using similar method, I want you to practice 50. You can, you don't need to practice 52 and 53. Okay, now does anyone have any equation? You will have one equation, one radical equation to solve for your exam 1. Okay, does anyone need help? Okay, now let me go to the next one, 1.5. Okay, 53, 54, 55. 54 and 55. So let me do one out of this. Okay, so this is an inequality, so we are solving an inequality. So let me do number 55. 53, 54 is very similar. So we have 5x minus 2 less than equals to 3x plus 7. So this is an inequality because we have less than equals to. So if we have less than, greater than, less than equals to, greater than equals to, not equals to, then this is an inequality. Okay, and we have this inequality, and inequality has infinite number of solutions. Okay, so solving means you are making your variable by itself in one side. So we have this term with a variable, we have this term with a variable. So let's collect these two terms together, and the method is very similar to solving an equation. So you subtract 3x on both sides. Okay, and this is a constant, so let's collect the constant on the right side. So you add 2 on both side. So 5x minus 3x, 2x minus 2 plus 2, that is 0. We have still less than equals to positive 3x, negative 3x, 0. 7 plus 2, 9. Now we have 2 with x, so we need to get rid of 2, and we divide by 2 on both sides. 2x divided by 2 is x. Now, whenever you are dividing both side of the inequality by positive number, your inequality signs remain same. Okay, you still have less than equals to 9 over 2. But sometime, like for example, if you have negative x greater than equals to 4, and in this case, you have to divide both side by a negative number. Okay, whenever you are dividing or multiplying an inequality by a negative number, your inequality sign changes. Okay, so negative x divided by negative 1 is positive x. Now instead of greater than equals to, you're going to switch it to less than equals to negative 4. Okay, so if you have less greater than, you switch to less than. If you have greater than equals to, you switch to less than equals to. If you have less than, you switch to greater than. If you have less than equals to, you switch to greater than equals to. Okay, you do this only when you are multiplying or dividing both sides of an inequality by a negative number. Okay, now we have to write our answer in an interval notation. So for that, use the number line. We have negative infinity on the left, a very big number, positive infinity on the right. So our x is less than equals to 9 over 2. Let's say 9 over 2 is somewhere here. Now here we do have a equals to sign. Okay, and if you have equals to sign, you're going to use a closed circle. If you don't have equals to sign, okay, if you have a equals to sign, you're going to use a closed circle. If you excuse me, if you don't have equal to sign, strictly less than, greater than, you're going to use an open circle. Okay, and closed circle means you are using bracket. Open circle means you are using parenthesis. Okay, now where do we find a number x which is less than 9 over 2? Is it on the left of 9 over 2 or right of 9 over 2? So less than means left. So we find the number on the left of 9 over 2 is a solution for this inequality. So in an interval notation, so you are starting from negative infinity to 9 over 2. We have a closed circle means we are including 9 over 2. 9 over 2 is also solution. It means we are using bracket. And with infinity, it's always parenthesis. And this is the solution for this inequality. Okay, does anyone have question here? Okay, looks like none of you have a question for me. The next one, 54, is very similar. Okay, I want you to practice. The next 55, 59. Okay, 55. That's what we did. 59. Okay. Let me do 59. And then next we have 61. 59, 61. Okay. Okay, let me do 59. Okay. So in 59, we have x minus 4 divided 3 greater than equals to -1 less than equals to 4. Okay, now this is the compound inequality. Okay, now this is the this has a 2 inequality in this form. Okay, so we can rewrite this as a, so this left portion together, so -1 less than equals to x minus 4 over 3. Okay, we use word and the right portion with variable. So x minus 4 over 3 less than equals to 4. Okay, so these two form are the exactly same, they are only in a different form. Okay, so you can solve by rewriting using word and, or you can still solve from here. Okay, so let me solve from the same expression. So that is -1 less than equals to x minus 4 divided by 3 less than equals to 4. Now we have the denominator 3, so we need to get rid of this 3. So to get rid of denominator 3, we multiply by 3, and you have to multiply both sides, okay, on the right and on the left. 3 times -1, -3, we have less than equals to, we are using positive number to multiply. Okay, so there is nothing changed in inequality sign, but if you are using negative sign, you have to flip this inequality, but we are using positive, so they remain same. So these 3 cancels, x minus 4 less than equals to 4 times 3, 12. Solving means we are making x by itself. Now we have -4, let's get rid of -4. You add 4, make sure you are adding on both sides. -3 plus 4, 1 less than equals to, this is 0, x less than equals to 16. Now this is the solution, and we want our solution in an interval notation. So on the left we have -infinity, on the right we have +infinity. So we have a number 1, so let's say 1 is here, we have a 16, 16 is, let's say, somewhere here. Okay, so x is greater than equals to, so equals to means we are using closed circle. So we have less than equals to with 16, so we are using closed circle. Okay, closed circle means bracket. Now where do we find a number x which is greater than 1 and less than 16? And the reason is, so we find the number greater than 1 and less than 16 in this region. Okay, so closed circle means we have a bracket here, bracket at 16. So our answer is 1 to 16, and we have a bracket. This is the solution for this inequality. Okay, does anyone have any question here? Okay. Now let's go to 61, 65. Okay, 61, 65. Okay, let me do 65. I think once we do 65, you should be able to do 61. So this is an absolute value equation. We have -3 plus 2 absolute value x minus 4 equals to 7. And if you have absolute value equation, you are writing absolute value expression in one side and the remaining on the other side. So we need to get rid of this -3, +2 from left. Okay, so to get rid of -3, you add 3 on both side. So we have, this is 0, 2 times absolute value of x minus 4 equals to 7 plus 3, 10. Now we also have 2. We need to get rid of 2. So for that, you divide both sides by 2. So this is absolute value of x minus 4 equals to 5. Okay. The next step, once you have absolute value expression by itself in one side, next step is we need to get rid of this absolute value sign. Okay. So we need to rewrite this absolute value equation without using absolute value sign. Okay. To rewrite that, you write down whatever you have inside the absolute value, x minus 4 equals to positive of right side, positive 5, or write down whatever you have inside the absolute value, x minus 4 equals to negative of right number, which is negative 5. Okay, so you need to get rid of this absolute value. Okay, and when you get rid of absolute value sign, you always end up getting two equation like this. Okay, and when you write two equation, there is no more absolute value sign. Now this is, now once you rewrite without using absolute value, we have a linear equation. So you add 4 on a both side, 4 on a both side. This is 0, x equals to 5 plus 4, 9, or x equals to, this is 0, negative 5 plus 4, negative 1. And these are the two solutions for this absolute value equation. Okay, let me know if you have any questions. Now the next, 66, 67. Okay, so number 66, absolute value of 3x plus 10 greater than 5. Now this is not an equation, this is an inequality. Okay, so this is absolute value inequality, and there are the two cases. Okay, so if your inequality has a less than sign, okay, so you can rewrite this inequality without using absolute value sign by, so this is, so if you have less than or less than equals to, so this is same as, so you write down whatever you have inside parentheses, not the parentheses, absolute value greater than equals to negative of this number, negative a, less than equals to positive of this a, positive b. The other kind is if you have absolute value expression greater than or greater than equals to some number, then this is, so you write down whatever you have inside absolute value, x less than negative of this number, negative a, or whatever you have inside absolute value, x greater than a. Okay, so these are the two different type, and you should be familiar with this. Okay, now in our case we have a greater than, so we will use this second rule. So here 3x plus 10, absolute value of 3x plus 10 greater than 5, so we have a greater than, so we need to rewrite this absolute value inequality without absolute value sign. So for that, you write whatever you have inside absolute value. We have 3x plus 10, then less than. So we have greater than, so we are writing less than negative of this number, negative 5, or okay, whatever you have inside absolute value, 3x plus 10 greater than positive of this number, which is positive 5. Now we don't have any more absolute value sign here. Now this turns into an inequality. We know how to solve. Subtract 10, subtract 10, subtract 10. This is gone, this is gone. So we have 3x less than negative 15, or 3x greater than 5 minus 10 minus 5. We get rid of 3, divide by 3, we are using positive number, so inequality remains same. 3x divided by 3 x less than -5 or x greater than -5/3. Okay, and we need our answer in an interval notation. For that, you draw a number line on the left -infinity, on the right +infinity. So we have these two number. So let's say our -5 is somewhere here and -5/3. This is the greater. So let's say over here -5/3. There is no equal to sign. Okay, so no equals to means you are using open circle. Open circle means you are using parenthesis. Now this is x less than -5. Less than -5 means on the left of -5. So this is this part, and x greater than -5/3. Greater than means on the right. So these are the solution. So from -infinity to -5, open circle means parenthesis, with infinity always parenthesis, or okay, from -5/3 to positive infinity, with infinity always parenthesis, we have an open circle parenthesis. Okay, now we use there is a notation to represent or. We use union. Okay, so we use union for or, and this is the solution for this absolute value inequality. Okay, does anyone have question here for number 66?
For clarification, we have to make sure that our answer includes the union symbol. We can't put the or symbol. We'll get points taken off for that.
Okay, if you only have like, if that's the only thing that you have, then you get the full credit. But if you have or, you just replace or by union. Okay, but yeah, that's not wrong. You will get the full credit. Okay, but yeah, if you are asked to write an interval notation, we don't use or, we use union. Okay, like for or we use union, and for and, if we have a two interval connecting with or and, we use intersection. Okay, so this is how we write when we are asked to write our answer in an interval notation. So it depends on the instruction. So if there is not a clear instruction to write an interval notation, you can leave up to here. This can be your solution. But if you are asked to use interval notation, then yes, you must have this portion. Okay. Now let me do 71. Okay, so let me do 71. This is also absolute value inequality. So we have absolute value -2x, -7 plus 4 less than equals to 8. Now we make our absolute value expression by itself in one side at first. So let's get rid of +4. You subtract 4. So we have -2x, -7 less than equals to 4. Now we go back to our rule here. So we have two rule. So this is, so we have our less than in our problem. So we're going to use this rule here. Okay, so see, we have a less than, and if you have a less than, absolute value inequality with a less than, then you write whatever you have inside absolute value, 2x minus 7, then greater than, we have equals to, so you include equals to negative of 4, negative 4, and on the right less than equals to positive 4. Okay, now we don't have absolute value, and we know how to solve this inequality. You add 7 to get rid of -7 from x. Sorry, we are adding 7 here. So this is 3 less than equals to, this is 0, -2x less than equals to 11. Now to get rid of -2, we are dividing every term by -2, and we are using negative here. Okay, so whenever you are dividing by negative, make sure to flip this inequality. So we have -3/2. For this less than equals to, we will use greater than equals to. Negative 2x divided by negative 2x. So for this less than equals to, we use greater than equals to negative 11 over 2. Now this is the solution. We use the number line, negative infinity, positive infinity. Now which one is the smallest? So this is the smallest, right? Which is on the left side, and this is biggest here. So this is on the right. Now you have equals to, means you're going to have a closed circle or a bracket. Now where do we find a number x which is less than negative 3 over 2 and greater than negative 11 over 2? And that is in these numbers. Okay, so in an interval notation, from negative 11 over 2 including this to negative 3 over 2 including this, and this is the solution for this inequality. Okay, let me know if you have any question. Okay, now like from exercise 1.3 from 9 to 14, I will pick one. Okay, everything is similar. So you are asked to write the number as a pure imaginary number from 9 to 14. So I will pick, let me pick number 13, and the remaining I'm pretty sure you should be able to solve. So we have negative 4 over 25. Okay, so this is the number given to us, and we are asked to write as a pure imaginary number. It means we are asked to write in terms of I. Okay, now this is, so we have negative under the radical sign. So for that negative sign, we replace negative sign by I square. Okay, then 4 over 25. Now square root of I square is I, square root of 4 is 2, square root of 25 is 5. So this is 2 over 5 times I, and this is the final answer. Okay, I think yeah, we are done with the review. Now let me know if you have any question. Does anyone have question up to now? You already have the videos on your modules, okay? And I can still upload this video if I'll try to upload this recorded video. If not, you can still access the review video on your modules. So if you have any question, I will wait like 5 more minutes. If not, you are free to leave. And if you have any question, you are free to ask me any question. Okay, looks like none of you have question for me. If that is the case, I'm gonna end this meeting. But if you have any question, please let me know. Okay. I wish you good luck for your exam and good night. I'm gonna end this meeting now. Bye-bye.